I'm going to proceed with the second example, which is going to be a little more complex. But it's not going to be complex to think about it. It's just going to be more convoluted. The math is going to be a little bit more involved. So the function here is y equals to 5x to the power of 3 minus 3x plus 2 to the power of 1/2. Again, we can see that there is an outside function and an inside function. The outside function is this to the power of 1/2. It's some z, it's this thing, 5x to the third minus 3x plus 2. This whole mass, that's to the power of 1/2. Okay, that's the outside function. The inside function is 5x to the third to the power of 3 minus 3x plus 2. So let's take the derivative of that. Okay, so the derivative dy dx, okay, it's going to be equal to the derivative of the outside function first. So what we want to do again, as usual, we want to take this exponent and we want to bring it down. So we use the power rule here. The exponent is 1/2, and then we bring it down, and then we generally write whatever is inside to the power of 1/2. So we just rewrite what we had before. So that's 5x to the power of 3 minus 3x plus 2 to the power of 1/2 minus 1. Okay, that's the power rule. This is the derivative of the outside function. We multiply that by the derivative of the inside function. So this is times the derivative of whatever is inside. So now we ignore this exponent and we just look at what's inside. What's inside is 5x to the third minus 3x plus 2. What is the derivative of that? Well, that's simply the sum of three different derivatives. The derivative of 5 times x to the power of 3 minus the derivative of 3x plus the derivative of 2. So start with 5x to the power of 3. That is 5 times, 5 we treat constants, the 5 as a constant, so we just rewrite it. 5 times now x to the power of 3, we apply the power rule. We take down the coefficient 3, we write again x to the power of 3, and we add a minus 2. That's the first component. Minus, I'm running slightly out of space here, the derivative of minus 3x, x has a power of 1, so again applying the power rule, it's 3 times 1 times x to the power of 0, which is simply 3. And then finally the derivative of 2, the derivative of a constant by itself is just 0, so this is it. Okay? Let's simplify this a little bit, and we get this, 1/2 5x to the power of 3 minus 3x plus 2 to the power of 1/2 minus 1, that is the power of minus 1/2. And this multiplies 5 times 3, which is 15x to the power of, oops, sorry, I made a mistake here, 3 minus 1, which is 2, so 15x squared minus 3. And this is your answer. Now, how do you like it? I think it's pretty ugly. It's not a nice function, but that is nonetheless the slope, the equation of the slope. Here I have a minus 1/2. There is from algebra we know that we can always turn negative exponent into positive exponents by bringing this in the denominator of these functions. So let's do that just for the sake of doing it. We can create this as a fraction. On the top we're going to have this side, 15x squared minus 3, and on the bottom we're going to have all this to the power of 1/2, or in other words the square root of 5x to the third minus 3x plus 2. Now at the point at x equals to 5, what we have is that the slope is, on the top is going to be 15 times x to the power of 2, so that's 5 times 5, so that's 25, minus 3. And on the bottom we're going to have the square root of 5 that multiply x to the power of 3, so that's 5 times 5, which is 25, times 5, that should be, oh, I think it's 125. if I'm not mistaken, minus 15 plus 2. And then I haven't solved it, but you need with a calculator, you can, or just by hand, you can easily get a number divided by the square root of another number. Again, it's going to look ugly, but who cares, right? We got the right solution. Okay, so that's the second example of the chain rule.